Now let's talk about collision domains. Now historically, or with older technologies, if two devices try to transmit at the same time, a collision occurred and the communication became garbled. Because of this, Ethernet devices use a technique called CSMA/CD. I know that's a mouthful and it looks complex, but it stands for Carrier Sense Multiple Access with Collision Detection. Now this technique is used to ensure only one device talks at a time in a collision domain. Now this means only one device can transmit or receive data at one time. And this is also referred to as half duplex. Now these packet collisions and half duplex transmission mode are more of a thing in the past when we used hubs or other non-sophisticated or immature forwarding technologies. I feel a little bad for referring to old technologies like that, but truly networks have developed so far from that. Now switches, which we also use in modern day, reduce the size of the collision domain effectively to one port, allowing multiple devices to transmit and receive at the same time. And this is also referred to as full duplex. Now switches make this logical separation by using the local MAC address table to map MAC addresses to the port. So let's look at a couple of diagrams here. Now this one is a demonstration of the different collision domains using older technologies on the left-hand side, with a hub presented in the middle, compared to a switched network on the right-hand side. So the dotted lines represent the collision domains in those different networks. So as you can see on the left, in the hub network, the entire network is one collision domain. Whereas in the switched network, the collision domains are contained on the single link. So in the hub network on the left, only one device can send or receive at the same time. And again, this is half duplex. On the switched network on the right, all devices can transmit and receive at the same time. This is of course a huge benefit and development since the old days. Now this is essentially how switches can create those logical separations and collision domains. So each MAC address on the host devices is mapped to the interface on the switch. Now we can actually take a look at the MAC address table on a switch. I have my Eve NG Lab open here, but let's see if there's actually anything there, because it may have timed out. So the command to view the MAC address table is show MAC address table. And it looks like we have some entries in here. I think those are the MAC addresses of the different switches that I have in this topology. I can show you that briefly here. So I have 3 switches connected in this way. We can actually ping between those 2 PCs, and then the MAC addresses should be populated on the MAC address table as well. Let's try that. So let's go on PC 1. And actually I have the information right here already, conveniently. So you can see the MAC address is right here for this device. And if I do the same command on PC2, show IP, here you can see the MAC address and also the IP addresses that I've configured. So let's copy this one. This is what we want to ping. Like so. And now let's see if those entries were added to switch 1's MAC address table. So let's run this command again. And yes, here you can see both of them were learned, and on different interfaces as well. So if we want to check that, so gig 0/0 is going towards switch 2, and then gig 0/1 is going towards switch 3. So then PC2's MAC address would be learned on this interface, and PC1's MAC address on this interface. So we can verify that. Let's look at this again. PC2's MAC address is the one ending in 05. So that should be on gig 0/1 right here. And this is correct. So the MAC address is learned from the source MAC address field in received packets, and then it is populated in the MAC address table. That's how the switch builds the MAC address table. All right, let's go back to the slideshow. So to wrap up the lesson, we talked about collision domains and how originally devices were only able to send at half duplex, meaning only one device could transmit or receive at a time. Then with the development of networks and the introduction of switches, the collision domains were effectively reduced to a single port. And the switches perform this logical separation by using the MAC address table to map the MAC addresses to a single interface. Those are the key takeaways from this lesson.